Here's our second lesson, or second part of lesson 2, and this is going to be on intercept form. So we just got done talking about vertex form. Now we have intercept form, which I'm sure you can tell by the name. If vertex form gave us the vertex, intercept form is going to give us at least one of our x-intercepts. So our kind of base function for intercept form is a x minus p x minus q, where p and q are going to be our two intercepts. So again, if it's my x-intercept, I would say that it would be p, and then whenever my x-intercepts, y has to be 0. Y always has to be 0 for your x-intercept. So again, if I just sketched this real quick, say I had any type of parabola like this, I would say here's a 0 and here's a 0. I could say that this is P0 and this would be Q0. And then how do I find my axes of symmetry? One way I could do that would be by taking P plus Q and dividing it by 2. Let me clear that up. P plus Q and dividing by 2. Again, I'm basically adding them up and I'm finding the average in between the two. Add them up, divide by how many pieces of data you have, that's the average. So let's look at an example. Graph a quadratic function in intercept form. Y equals 2, x plus 3, and x minus 1. So if I were to draw this out, I'm going to say one, two, three, 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, -4, -5, -6. So again, identify the x-intercepts. It's my first step. So I see that I have a +3 and a -1 here. So again, this can be tricky, but again, because it's x minus -3, my p-value is actually -3. So p equals -3, which I would say is -30. So my first point is going to go right here. And then again, this one is kind of normal. It's just x minus q. So q is going to be 1, 0. So here are my two x-intercepts. Now I have to find the coordinate of my vertex. So again, if I find the average distance in between my p and my q, that will tell me where my vertex is because this is symmetrical. So I'm going to say, okay, my formula I'm going to use to find the x value at least is p plus q divided by 2, -3 plus 1 divided by 2, -2 over 2, x is -1. So I know that this is going to be where my x value is going to be, but I don't know where my y value is yet. So I'm going to take my original equation and plug it in. So every time I see an x, I'm going to plug in a -1, and I'm going to solve. So again, this is what I'm changing right here. I got this number right there. 2, -1 plus 3 is 2. -1 minus 1 is -2. 2 times 2 is 4. 4 times -2 is -8. So my y value is -8. So again, my vertex is going to be -1, -8. So it looks like I have to make my graph slightly longer right here. And because I have my x-intercepts and my vertex, I can graph. That wasn't a very good graph. Hopefully you can do a little better than I just did there. Let's redo that. Better. Again, this right here is not good. I would need to fix that, okay? Now, intercept form can kind of be useful because, again, oftentimes we may think about it like some like real life problems. So a classic kind of problem for this situation is someone's kicking a ball. So let me put this picture in here. All right. So we've got this football player who's punting the football. And we can say that this punt is going to form, the path of the ball is going to be kind of like an equation. It's going to be modeled by an equation like this. So our equation is going to be y equals negative 0.026x, and it's going to be x minus 46, where x is the horizontal distance and y is the height. So how far is the football kicked, and what is the football's maximum height? So again, there's basically three super important points. You've got your intercepts, and you have your maximum height or your vertex. Now, I guess it would be more accurate to say a place kicker, not a punter, because a punter drops the ball. And if you think about it, he doesn't technically kick the ball off the ground, where if he's like a place kicker doing the kickoffs, he would be kicking off of the ball. So boo to the math book for not using proper football terminology, but that's okay. Now, let's go ahead and say, well, we know that one of my vertexes is 46 because that's given to me. Now this one looks a little funky. So, but that's okay, because I could rewrite this equation as x minus 0, x minus 46. Again, subtracting by 0 does not change my equation. So I'm going to say that, hey, my two zeros are, or my two x-intercepts are at 0 and at 46. So if the question is asking, how far is the football kicked? We would say, well, it's not going to be 0. It would be 46 yards where the football lands right here. And then the second part of the question is, how high is the football kicked? So again, if I think about, well, I know I have a 0, I have an x-intercept of 0 and an x-intercept of 46, I can find my x-coordinate by doing p plus q divided by 2. And in this case, p is 0 and q is 46. So that means my x-intercept, my axis of symmetry, is going to be at 23. So I've got my x-coordinate, which is 23. Now I'm going to take my original equation, y equals negative 0.026. Every time I see an x, I'm going to plug in a 23, and then I'm going to solve. Now I'm going to go ahead and use my calculator. So we could say, all right, well, there's a couple ways we could do it. We could plug it in and just solve it, like just using a very basic numerical calculator. So I could say negative 0.026, parentheses 23, parentheses 23 minus 46, and I would get about 13.754. So if I were to say, okay, y equals 13.754, so my vertex is 23, 13.754. And because our units were yards, we would say the ball was kicked 13.754 yards high. Again, another way you could do it is use your graphing calculator, type in the equation with the x's, and then you could click on the maximum value and it would tell you what that value is. So we can, again, move. So we've got three different forms. We have standard, vertex, and intercept form. And we can move from one form to the other. So say I start with an intercept form and I want to go to standard form. Intercept to standard. I could say that y equals -2, x plus 5, x minus 8. So what I would do is I would just use my FOIL method, which again tells me to multiply my first term into each term, and then I take my second term and I multiply it into each term. I think it's easier to do your parentheses first and then keep that -2 for the end. So let's do x times x is x squared, x times -8 is -8x, 5 times x is 5x, 5 times -8 is -40. Before you multiply, you better combine like terms. So I'm going to have -2 x squared minus 3x minus 40. And now I can use the distributive property one more time to get an answer of -2x squared. Negative times a negative is a positive. Negative times a negative is a positive. So I successfully moved from intercept form to vertex. To standard form. Again, we know different things. So maybe you say, hey, I've got the vertex. I got to move it to intercept form. Hey, I've got standard form. I want the intercepts. I got to move it to intercept form. So you always want to kind of revert. If you've got intercept, you can go to standard, and then standard can go to vertex. Vertex can go to standard, and then standard can go to intercept. So we'll do one more example. This time we're going to do vertex to standard. And that's going to be, so again, f of x equals 4, x minus 1 squared plus 9. So remember, a squared just means repeated multiplication. So this is like saying x minus 1 times x minus 1. Still have that. Now I got to do this distributive property one more time. Again, keep the 4 on the outside. X squared minus x plus 1 plus 9. Find your like terms. I forgot an x squared. Equals 4x squared minus 2x plus 1 plus 9. Now I'm going to take my 4 and multiply into each term and get 4x squared minus 8x plus 4 plus 9. And I've got one more set of like terms to get 4x squared minus 8x plus 13. That's it for today.